Section 2.1, Applications of limits. Limits have many applications. In the section 2.1, I will show you two applications. The first is a limit can be used to find the slope of a tangent line. The second is a limit can be used to find the instantaneous velocity of a moving object. Today, two topics. Topic 1, take a review about the slope formula and the equation formula of a line. Second topic, use limit to find the slope of a tangent line. In the next class, I will show you use limit to find the instantaneous velocity of a moving object. Now, topic 1, a review about the slope formula and the equation formula of a line. Suppose we have a line. How to tell the slope of this line? Arbitrarily pick 2 points on the line, say point P, point Q. Then the slope formula is y2 minus y1 over x2 minus x1. This formula. In our textbook, slope is denoted by m. M means slope of a line. Please note that no matter how you pick the 2 points on the line, this formula will give the same slope. The slope by this formula doesn't depend on the points that you choose. Here is one example about the slope formula. Part A, find the slope of the line that passes through these 2 points. By the slope formula, the slope is y2 minus y1 over x2 minus x1. y2 is 3, y1 is negative 1. x2 is 3, x1 is 1. So we have 3 minus negative 1 over 3 minus 1. So the slope of this line is 2. Part B. Find the slope of the vertical line x is equal to 1. The graph of this equation is this vertical line. The graph is the set of all the points that satisfy the equation. All the points that satisfy this equation are the points on this vertical line. Now, I want to tell the slope of this line. How? Arbitrarily pick 2 points on the line. Say, I pick this point and this point. This point is point P. X and Y coordinates are 1, 0, and this point is point Q. X, Y coordinates are 1, 2. Then, by the slope formula, slope is y2 minus y1 over x2 minus x1. y2 is 2, y1, 0. So 2 minus 0. x2 is 1, x1 is 1, so 1 minus 1. So we get 2 divided by 0. 2 divided by 0 is infinity. So the slope of this vertical line is infinity. Part C. Find the slope of the horizontal line y is equal to 1. The graph of y is equal to 1 is this horizontal line. All the points that satisfy the equation y is equal to 1 are the points on this horizontal line. Now, to tell the slope of this horizontal line, arbitrarily pick 2 points. Say I pick this point, pick this point. This point is point P. X coordinate is 0, Y coordinate is 1. This point is point Q. X coordinate is 2, Y coordinate is 1. Then by the slope formula, y2 minus y1 over x2 minus x1, it is 1 minus 1, right? 1 minus 1. Then over x2 minus x1 is 2 minus 0. So we get 0 over 2. It is 0. Therefore, the slope of this horizontal line is 0. Now, we turn to the equation formula of a line. Suppose we have a line, and suppose we know the slope of the line, and also we know one point on the line. Then the equation of this line is y minus y1 is equal to slope times parenthesis x minus x1 parenthesis. In this equation, x and y, they are variables. x1, y1, they are constants. They are the x and y coordinates of the point P. All the points on this line satisfy this equation. Or in other words, the graph of this equation is this line. Some people call this equation the point slope formula of the equation of this line. Now, two examples about this formula. Example 1. Find the equation of the line L that has slope 2 and y-intercept 3. Line L is this line. It has y-intercept 3. That means that the line cuts y-axis at 3. To write down the equation of this line, we need to know the slope of the line and one point on the line. The slope of this line is 2, we are given. One point on the line is this point, we know this point. This point, x coordinate is 0, y coordinate is 3. This point is the point P here. Then by this formula, the equation of this line is y minus y1. y1 is 3. It's equal to slope. Slope is 2. Parenthesis x minus x1. x1 is 0. Then simplify this equation a little bit. Then we get this equation. This is the equation of this line L. All the points on the line satisfy this equation. Or in other words, the graph of this equation is this line. Second example. Find the equation of the line L passing through these 2 points. Suppose this line is line L, and negative 2, 1 is this point. 3, 7 is this point. Now, we want to write down the equation of this line. To write down the equation, we need to know the slope of the line and one point on the line. We are given 2 points, so one point on the line is not a problem. The problem is we need to determine the slope of the line. By the slope formula, slope is y2 minus y1 over x2 minus x1. We have 2 points. Which point is y2? Which point is y1? It doesn't matter. Say, suppose this point is y2. This point is y1. Then y2 is 7. y1 is 1. x2 is 3, x1 is -2. Then we have this equation, 7 minus 1 over 3 minus -2. So the slope of this line is 6 over 5. Now we have slope. Now we need one point P. We have 2 points. Which point we should choose as the point P? It doesn't matter. Say, let me pick this point as the point P. Then the line equation now is y minus 7. This is a point P. Y minus 7. Then slope is 6 over 5. 6 over 5. Parenthesis x minus x1. This point is point P. X coordinate is 3. So x1 is 3. Simplify this equation a little bit, then this is the answer to this example. The second topic today, find the slope of a tangent line. About this topic, I want to show you 2 examples. Example 1. Consider this function. This function is a polynomial of degree 2. The graph of a polynomial of degree 2 is a parabola. Because the leading coefficient of this function is negative, so this parabola is open downward. Here, I use my computer plot the graph of this function. The graph is this parabola. It is open downward. Now, 2 questions. Question A. Find the slope of the tangent line to the graph of this function at the point P. The point P, x coordinate is 1. Y coordinate is f of 1. Whenever y coordinate of a point is function value, the point must be on the graph of the function. Point P is on the parabola. Point P is here. How to get the function value at 1, f of 1? Plug in 1 in the x here. Then f of 1 is equal to -2 times 1 square plus 12 times 1. It is 10. Function value at 1 is 10. Now, at the point P, there is a tangent line. Let me name this tangent line by T. Now the question A is, we want to find the slope of the tangent line T. Okay. In notation, slope is M, so we want to find MT. T means tangent line. To find the slope of a line, we have the slope formula. But this formula requires we load 2 points on the line. Now, about this tangent line, we load only 1 point on it. The point is 110. We don't load any other points on the tangent line. Say, for example, can you exactly tell me the x and y coordinates of this point? If you can, then I can tell you the slope of the tangent line. This is the difficulty of finding the slope of a tangent line. We load only 1 point on the tangent line, so we cannot use the slope formula. Now, to overcome this difficulty, to find the slope of a tangent line, we have to use a limit. Now, on the graph of the function, I arbitrarily pick a point, point Q. Because the point Q is on the graph of the function. The y coordinate must be function value, f of x. It is negative 2x squared plus 12x. Yeah, here. Okay, now I join point P and point Q with a 9. About this 9, I load 2 points on it, point P and point Q. So I can write down the slope of this 9 by the slope formula. By the slope formula, the slope of the line PQ is y2 minus y1. y2. y1 is 10. Over x2 minus x1. x2 is x. x1 is 1. Remove the parentheses, then we get the slope of the line PQ is this. This depends on variable x. Okay, now I let x approach the point 1. X is here. The point 1 is here. Now I move x toward the point 1. As I move x toward the point 1, the point Q will approach the point P along the parabola. Yeah, point Q will approach the point P along the graph of the function. Hence, the secant line PQ will approach the tangent line. When the point Q approach the point P, the blue line, the secant line, will approach the tangent line, the red line. Therefore, the slope of the line PQ will approach the slope of the tangent line. Because the blue line approach the tangent line, so the slope of the blue line will approach the slope of the tangent line. In other words, in the limit notation, the slope of the tangent line is the limit of the slope of the line PQ as x approaches 1. Slope of the line PQ below it, it is this, okay? So I can put this here. So to find the slope of the tangent line, we just need to determine this limit. For the convenience of my presentation, let me copy this limit here. Now to find this limit, I make this table. The first column of the table is for x, independent variable. The second column, I let the second column for the point Q. The third column, I let the third column for the numerator of this quotient. The fourth column, the denominator of this quotient. The last column is this quotient. This quotient is the slope of the line PQ. Slope of the line PQ. Now, in this table, I let x approach 1 by taking on these points. When x is 2, the point Q is 216. 216 is here. Is here. Yeah. When x is 2, the numerator is 6. Denominator is 1. So the quotient is 6 over 1. 6. 6 is the slope of the line PQ when x is 2. Yeah. This line, this blue line, the slope is 6. Now, from this table, we can see that as x approaches 1, point Q approaches the point P. And the slope of the line PQ approaches the number 8. So therefore, this limit is 8. Because the slope of the tangent line is equal to this limit. So the slope of the tangent line is 8. Part B of this example. Write down the equation of the tangent line. From part A, we obtain the slope of the tangent line. It is 8. Now we have the slope of the tangent line, and also we know one point on the tangent line, point P. Then by the point slope formula, we can write down the equation of the tangent line. The answer is here. Y minus y1. Y1 is 10. It's equal to slope. Slope is A. The tangent line, the slope is A. Parenthesis x minus x1. x1 is 1. So this is the equation of the tangent line, the red line. Example 2. This example is similar to the last example. Consider this function. The graph of this function is this curve. Now, 2 questions. Question A. Find the slope of the tangent line to the graph of the function at this point, point P. X coordinate is pi over 2. Pi over 2 is about here. The y coordinate is function value at pi over 2. Because the y coordinate is a function value, point P is on the graph of the function. Point P is here on the graph of the function. The function value at pi over 2 is plug in pi over 2 in x here. Then f of pi over 2 is 1 minus cosine pi over 2. Calculator. Function value is 1. So 1. Now, at the point P, there is a tangent line. Again, I name this tangent line by T. Now, the question is, find the slope of this tangent line. About this tangent line, we know only one point on the line, the point P. We don't know any other point on the line. So we cannot use the slope formula to find the slope of the tangent line. Then, how to tell the slope of this tangent line? We have to use a limit. On the graph of the function, arbitrarily pick a point, point Q. Because point Q is on the graph of the function, the y coordinate must be function value, the function at x. Okay, function at x is 1 minus cosine of x. So this y is 1 minus cosine of x. Now, join P and Q with a line. About this line, we can write down its slope because we know 2 points, P and Q, on the line. By the slope formula, the slope of the line PQ, I call this line PQ. The slope of the line PQ is y2 minus y1 over x2 minus x1. y2 is 1 minus cosine of x. y1 is 1. x2 is x. x1 is pi over 2. Cancel the number 1, then we have this. This is the slope of the line PQ. Now we apply a limiting process to obtain the slope of the tangent line. We let x approach pi over 2. X is here, pi over 2 is here. Now we move x toward pi over 2. As x is approaching pi over 2, from this diagram, we can see that the point Q is approaching the point P along this curve. As point Q approaches point P, then the blue line is approaching the tangent line. So therefore, the slope of the blue line is approaching the slope of the tangent line. In other words, slope of the tangent line is the limit of the slope of the line PQ. Line PQ is the blue line as x approaches pi over 2. Here we have obtained the slope of line PQ. So we plug in this in MPQ to get this limit. So to tell the limit of the tangent line, we just need to compute this limit. Again, for the convenience of my presentation, I copied this limit on the last page. I copied that limit here. Now, to find the limit, I make this table. The first column is for x, second column for the point Q, this column for numerator cosine, and this column for the denominator. And the last column is this quotient. This quotient is the slope of the line PQ. Now, I let x approach the point pi over 2 by taking on these points. For example, when x is pi over 2 plus 0.5, the corresponding point Q is this point. In graph, the point Q is here. Yeah, this point is pi over 2 plus 0.5. This blue line, the slope of this blue line is, from the table, the slope is 0.95, 88, 51, 08. From this table, we can see that as x approaches pi over 2, the slope of the line PQ is approaching 1. So therefore, this limit is 1. Because the slope of the tangent line is equal to this limit, so the slope of the tangent line is 1. After we have the slope of the tangent line, it's easy to write down the equation of the tangent line. The slope of the tangent line is 1, and also we have one point P on the tangent line. Therefore, by the point slope formula, the equation of the tangent line is y minus y1. y1 is 1. Is equal to slope is 1, times parentheses x minus x1. x1 is pi over 2. This is the point slope formula in topic 1.